Happy Friday, everybody. I wanted to talk about hyper and hypoventilation just for a few minutes here. I know we didn't quite get to this experiment in some of our lab groups, so I wanted to take just a second and show you a few things about hyperventilation and hypoventilation to make sure that you are prepared for the lab. So as you can see on my screen here, this is an example of normal data if the subject was sitting down at rest, just normal breathing. So the patient or the test subject would be seated. There's a couple of ways that we could test this. One of the ways, we could put a mask on the face and measure respirations, or we could put a little sensor right around the chest to measure the rising and falling of breathing during respiration. So for this, if we were to just breathe normally as such, didn't that feel nice? Okay, you can see here the rising and falling with inspiration and expiration. Notice how close, or the intervals between breaths. Now we're going to have the patient or the test subject breathe and talk. Notice that I am only talking while exhaling. So here I can see normal breathing, and then when I get ready to exhale, I am talking. So we can see there the breath movements moving depending on my voice inflections. We can see what that would look like graphically. Now if I want the patient to hyperventilate. Hyperventilation means breathing rapidly or above the normal respiratory rate. So what I want you to notice about this graph right here is we have normal respiration occurring first, followed by very quick breaths here for just a few seconds, and then you see we begin to normalize again. So what that would look like would be normal respirations, followed by all right, and what we experience when we are hyperventilating is something known as hypocapnia. And hypocapnia is a fancy term for low CO2 levels in the blood, or another way we could put it, low carbonic acid in the blood. So as the carbonic acid levels decrease, that means that my pH level is increasing, which is going to lead to a condition known as respiratory alkalosis, which means that my blood pH is now becoming more alkaline or more basic. And we talked about in class that normal blood pH is going to be around 7.35 to 7.45. So in this case, I have too much oxygen, not enough carbon dioxide, and I'm now shifting more toward the alkaline side of my pH. So this is hyperventilation. So if hyperventilation was overbreathing, then hypoventilation would be underbreathing. So it would look more like this. All right, so we can see here deep breaths in followed by deep breaths out. And when we are hypoventilating, that's going to lead to a condition known as hypercapnia, which is too high of a CO2 level in the blood, or a higher level of carbonic acid, which is going to lead to respiratory acidosis, which means that the blood pH is now becoming more acidic. We can also have a condition here known as hypoxia, which means low oxygen levels. So something I want to show you here, we're going to scroll back up. This was normal at rest breathing. Notice where the lower point here of my waves, or my trough, in normal respiration. Now let's look at it down here in hypoventilation. Look how low those are coming down. So even though we should be able to see that those waves are further apart and they are deeper. So things you would have to know about this. If I gave you a section of a graph, you've got to be able to identify, is it normal breathing, so regular respiration? Is it hyperventilation or is it hypoventilation? And then you have to tell me what's going on with the patient. What are they experiencing? Is it hypercapnia or hypocapnia? Are they experiencing respiratory alkalosis or respiratory acidosis or possibly even hypoxia? So I have created this little chart for you here, and I'm going to post this to your Blackboard, but you can see here in hyperventilation, we do have hypocapnia and respiratory alkalosis, which is giving us here low levels of carbonic acid, which is causing blood pH to rise, hydrogen ion concentration to decrease or go down. Hypoventilation, we're experiencing hypercapnia, hypoxia, and respiratory acidosis, which means that we have higher levels now of carbonic acid in our bloodstream, which causes the blood pH to decrease. And you and I both know, because you've been studying, that as blood pH decreases, hydrogen ion concentration now is increasing. So hopefully now you have a little bit better take on hyperventilation and hypoventilation. It's going to play a very important role in 2402 when we get to respiration, obviously, and also when we get to acid-base balance. So something super crucial for lab, I will have the simulation set up for us for sure before we do practical, but I just wanted to make sure that you guys had a little bit of an idea what was going on. I hope you guys have a fantastic Labor Day weekend. Try to get some rest and make sure that you study. And as always, you need yourself a little joke. So remember, if I were an enzyme, my name, no, I said that totally wrong. Bing! Try again. Let's try again. Okay. If I were a DJ, that's better. All right. If I were a DJ, my name would be DJ Enzyme, because I'm always breaking it down. Have a good weekend, you guys.